Okay, we're factoring by grouping today. Last year and a few weeks ago, we factored quadratics. In IM3 now, we're going to be factoring cubics. So if we look at our first example, I have a cubic polynomial, 16x cubed minus 4x squared plus 12x minus 3. Okay. So when I'm factoring by grouping or when I'm factoring, what's the very, very, very first step that I have to do? The first thing, all the way at the beginning. What? Yes, I have to see, do I have a GCF? Now, on number 1, do I have a GCF? No, okay. So if I don't have a GCF, what do I do next? But how do I factor? Yeah, don't I split it down the middle? Because I have 4 terms already, right? With our quadratic, we had to find the middle 2 terms. But now I'm starting with 4 terms. So I can just start by splitting it down the middle. Okay. So we're already like a step ahead now. After this, I find my GCF, which is what? 4x squared, like that, right? Okay. So what is 16x cubed divided by 4x squared? 4x. Good. Whoops. I have 4x squared, and then you told me it's 4x. Good. And then what is negative 4x squared divided by 4x squared? What kind of one? Negative 1. I heard one of you. I have 30 some odd more than that. Okay, now, out of 12x minus 3, what is that GCF? It's going to be a positive 3. So I'm going to write plus 3. And what am I left with? 4x minus 1. Perfect. So that means I have 4x minus 1 times 4x squared plus 3. And that's my answer. That's it.
So
we're basically just factoring. Can you try the second one before I move on and give you some more things to do? Can you try the second one? Yeah. Okay, we're going to check this answer. It's x squared minus 3 times x minus 4. Is that what we got? Did we do it successfully? Okay, so now before I move on, we're going to have to backtrack a little bit to multiplying. Okay, so before we can continue to factor, we're going to have to practice some more multiplying. So I have x plus 1 times x minus 1, 2x plus 3 times 2x minus 3, 3x minus 4 times 3x plus 4. What do you notice about the 3 different problems that I've given you? They're all plus or minus, and what does that mean? Like they're the same, but different. Okay, so they're the same factors, but with different signs in them, right? Okay, do you remember when we were talking about difference of 2 squares a few weeks ago? Does it sound familiar? I'm not asking you, do you know how to do it? Do you remember us talking about it? We did like maybe one example of it. Okay, if not, that's fine. Okay, so x plus 1 times x minus 1. To get that answer, I'm going to show you what the answer is. I get x squared minus x plus x minus 1. How do you think we can get this? Yeah. Doing the box method or FOIL or distribute or whatever it is that you call your method. So let's see that. I'm not going to do it for all of them, but we're going to practice it for this one so we know where these numbers are coming from. So I have x plus 1 times x minus 1. So I get x squared, negative x, positive x, and negative 1, right? So if I'm simplifying, these are my like terms, aren't they? Negative x and positive x?
Yeah.
What happens? I add them, but what do I get? Yeah, it's a 0 pair. So that means I end up with x squared minus 1 as my answer. Okay. So I get x squared minus 1 because those 2 middle terms become a 0 pair. And the reason for that is because my factors are positive and negative, okay? So I'll get the same thing, but since the signs are different, I get a 0 pair for those 2 terms, okay? So another way of showing that is we circle them, they cancel out, and I get x squared minus 1, okay? Another way to do this is to say, what is my first term? What is my first term from those factors? It's an x. And what's my second term? 1, okay? If I square both of these and throw in a subtraction, what am I going to get? What is x squared? What does that simplify to? Just stays as x squared. And what is 1 squared? Isn't that the same thing? Did I have to do the box method? Did I have to FOIL? Did I have to distribute? No, because we're talking about a difference of 2 squares. So before I show you the answers to the second one, let's try to do that same idea. So what is my first term on the second problem? 2x. And I'm going to square the whole thing. What is my second term? 3, and I'm going to square the whole thing, and I'm going to throw a subtraction on there. Okay, every single time. What is 2x quantity squared? 4x squared. Good, because 2x times 2x is 4x squared. What is 3 squared? 9. Drop down to negative, okay? Do you remember a few weeks ago we were working backwards? Remember I said take the square root of both of these terms to find the factors? Now we're going to be working forwards and backwards. So I have 4x squared minus 9. Let's check our answer, okay? So this is what I'd get if I did the box method. What are the two terms that create a zero pair? Negative 6x and 6x. And is that the answer that I got? 4x squared minus 9? Yeah? Did I have to do that much work? No. Do you say it's confusing? What's your question then? Okay, so we're going to look at this last one, okay, Alexis? Okay, on the last one I have 3x minus 4 times 3x plus 4. Can you tell me what is the first term that I have? Good, okay. So whatever my first term is, I'm going to square it every time. And then what's my second term? 4, good. And I'm going to square that as well. And then what did I do for all of them? What's the same every single time? I'm going to put a subtraction sign. That part doesn't change. Okay, Alexis, now what is 3x times 3x? 9x. Good. And what is 4 times 4? 16. And I still have the subtraction. So that should be my final answer, okay? Now if you need to do the box, go ahead. But I need you to get a little bit more fluid and fluent with our special factors, okay? So if we check it, what's my zero pair here? 12x and negative 12x. Did I get 9x squared minus 16? Yeah, so that's the same answer. So here's what we have. We have factor difference of 2 squares. Can you write this into your notes? All that means is that the first term squared minus the second term squared is going to be first plus second, first minus second. That's how we write it. Okay. So pretty much take the square root of both terms, throw a plus or minus on there. So my next example is x cubed plus 7x squared minus 4x minus 28. Okay. Was my very, very, very first step every single time. Find the GCF. Do I have a GCF? No, you guys just like flipped a switch and fell asleep or something. There's no happy medium between quiet and not quiet. Okay, so there's no GCF. So what do I do if there is no GCF? Draw the line down the middle. Yeah, you fell asleep, huh? Okay. So once I draw the line down the middle, what is the GCF of my left-hand side? Do we all agree it's x squared? Yeah. Am I moving too fast or is this okay? Okay. So what is left over when I factor out an x squared? X plus 7? Yeah? Okay, now on the right side between negative 4x and negative 28, what is the GCF here? Negative 4, perfect. And I'm left with x plus 7, amazing. So I have x plus 7 times x squared minus 4. Am I done factoring? Is that my answer? No. Okay. The reason for that is because this x squared minus 4 can continue to factor, okay? Is x squared a perfect square? Can I take the square root of x squared? Okay. Can I take the square root of 4? Then that means I can continue to factor it, okay? So what is the square root of x squared? x. And what is the square root of 4?
Negative 2.
2. And then I'm going to put a plus or a minus. And then bring down my last factor. Now, can x plus 2 times x minus 2 times x plus 7 be factored any further? No, this is my final answer, okay? Now I have a question for you. So the factor that I had was x squared minus 4. What if I had x squared minus 7? Could I continue to factor that? No. Why not? Because 7, I can't take the square root of it. It's not a perfect square. What if I had 3x squared minus 4? I can take the square root of 4. Good. I can take the square root of x squared. But what about 3? No, so I still can't factor it. What about if I had x squared minus 16? Yes. What if I had 9x squared minus 16? Yes. What if I had 9x squared plus 16? No. It has to be subtraction, because when we have the plus, that's when we start to get into imaginary numbers, and we're not doing that quite yet in this unit, okay? So 9x squared minus 16 is okay, because they're both perfect squares, but 9x squared plus 16 is no good because it's not a difference, okay? It has to have that subtraction sign. So if it was 9x squared plus 16, you would just leave it like that, and that would be your answer, or that would be one of your factors, okay? But this one could be factors, so I have x plus 2, x minus 2, x plus 7, and you can write those three factors in any order, okay? Now on number 4, what's my first step? GCF. Do I have a GCF this time? Yes. Yes. What is my GCF? 2. Perfect. Okay, so I have 2 times x cubed plus 8x squared minus x minus 8. I'm just going to rewrite it. Okay. After I check for my GCF, what is my next step? Draw my line down the middle. Now, if you can factor without drawing a line every time, be my guest. I'm going to do it in all of my notes just so that you don't know, like you don't get confused where everything's coming from, but this is how you do it. Now, on the left side, what is the GCF between x cubed and 8x squared? X squared, good. So I have x squared times what? Good. And now what about between negative x minus 8? Perfect. And I'm left with another x plus 8. So I have x plus 8 and x squared minus 1. Am I done? Did I even write it correctly on that line? Or am I missing something?
Oh, you're missing the 2.
Oh, I forgot the 2. Okay, you have to remember the 2. I guess I need to remember the 2. If you wrote it good, I'm glad. Now, is that my answer now?
Yes.
Oh, I'm done? You can guarantee I'm done. Can I take the square root of x squared? Can I take the square root of 1? What's the square root of 1? 1. So, that means the square root of x squared is x. The square root of 1 is 1 plus minus x plus 8 and 2. So we need to know what our perfect squares are. We have 1, 4, 9, 16, 25, 36, 49. Yes.
When you put x plus 1 and x minus 1, do you want us to put it like that, or could we put x plus or minus 1?
I prefer it like this because we're going to get into solving like next week when we set it equal to 0. And when you all write x plus or minus 1 and you're trying to set it equal to 0 and you're like, okay, I don't know what to do now because it's a plus or minus. So I would rather have you separate it in the factors. In your final answer, if it was a solution and you wrote plus or minus 1, that's okay. But in factors, I want you to keep them separate, okay? And it'll make it easier too because we're going to be reading graphs this week and next week. And it's just a little bit more easy to see visually, okay? Good question. Ready for 2 more examples? I have 2 more and then you have some you tries. Okay, number 5. I have 9x cubed plus 36x squared minus 4x minus 16. Do I have a GCF?
You don't.
No, I don't. Okay, because some of the numbers are divisible by 9, some of them are divisible by 3, some of them are divisible by 4, but none of them are divisible by all of them. So no, I don't have a GCF. So between 9x cubed and 36x squared, what is my GCF? 9x squared, good. So I'm left with x plus 4, right? Okay. What about on the right side? Negative 4x minus 16. Perfect. Negative 4. And I'm left with x plus 4. So I have x plus 4 times 9x squared minus 4. Am I done? No. Why not?
3x plus 2.
Because I can take the square root. So I have 3x plus 2 and 3x minus 2. And does the order of that matter? No. Again, it does not matter to me. You just need to have the factors. Okay? Now that's my final answer. Does this make some more sense? Question? Stretching. Okay. Finally, number 6, and then I have some U-tries for you to do the rest of the class. I have 4x cubed plus 12x squared plus x minus 3. First step. Is there one? No. So next step. Line. Okay. Right, left side. What is my GCF? 4x squared. Perfect. So I'm left with what? Awesome. And then right side, GCF. Okay, negative 1. And what is x divided by negative 1? Negative x plus 3. Is that right? Okay, so let's try positive 1. What do you think of that? Let's check positive 1.
Oh, no, you can't do that.
So I'm going to change all my signs. Now, is that right? Did these match? No, they didn't match either way. So this is not factorable. So we're going to write not factorable. I don't want you to write no solution because there could be one using a method that we don't know how to use. But on these factor problems, I prefer that you write not factorable, okay? You ready for the U-tries? Okay, there's 4 of them, and you have 8 minutes. That is plenty of time. Oh, yes, it is. Okay. Maybe with how fast he writes, it's not enough time. Can you try these 4? You can work in your groups, ask for help. You're doing really well, so I know you can do it. I'll give you the rest of the time. Okay, here are your answers. Hurry up, Diego. The bell's gonna ring.
Go without it. Please, go without it.
Okay, check your answers, please.
I got it.